exam. Okay, this is the last exercise 0.3, and then Friday we will go over some of the kind of review problems. Just pick question from each section, and we try to cover some of the as a practice. So we do that, and then all the homework we'll do Friday, no Saturday. So then you can manage the time depending on how fast you go. Okay, so what we want to do today, we want to finish, we want to talk about something called trigonometric substitutions. Trigonometric. Because there are some integrals that you cannot do using any other methods. So what we try to do, we try to bring certain type of integrals into the form that we discussed in 7.2. Remember what we did in 7.2? We talk about trigonometric integrals. So what we try to do, we talk about some kind of special substitutions. We bring these kind of factors into something into trigonometric integrals, and then we do the trigonometric. Okay, that's what we do. That's why we did 7.2 before 7.3, because we ultimately gonna bring these integrals into 7.2, okay? And then we do the way we did with 7.3. But some are very easy, you don't need to do much, but some like we need to do the 7.2 part. Okay, so let's start. Okay. So before we start, so what we try to do are trigonometric substitutions. Trigonometric substitution.
Is it 7.2 or 7.3?
7.3. I don't want to go out of 7.2. It looks like. Let's go to 7.3. Okay. So before we start, remember some of the shortcuts that we discussed in chapter 5, the first week. So I'm going to recall two of them. The most important one is if we have a function to a power and you have the derivative of the function. So if you get these kind of questions, this is basically a substitution problem, but you don't have to do that. You can write the answer right away, because it's a substitution, but once you have the derivative, this becomes much simpler. This is just the fx n plus 1 over n plus 1 plus c. So you can just write it like that, but you have to have the derivative there, exact derivative. Whatever extra, you have to write it outside, like numbers. We use this a lot. Last time also we used this one in the last question. We did that last example. And then when we have a function and its derivative like that, this is also a substitution problem, but we don't do it that way. We just consider this as just the natural log fx plus. So just remember these two. These are two shortcuts. Okay, you can just write it. If you have the derivative, you have to have the derivative. Okay, now given that, what's the answer for this this problem? So one such example is this x 4 minus x squared dx. So what's the answer? What is the fx in this problem? What is fx in this problem? 4 minus x squared. So what is the derivative of that? Negative 2x. Okay, so that means we are missing negative 2. That we can easily handle. Is that right? That's perfect, right. So you have the function and the derivative. So you can use the power rule. So the answer is negative 1/2, the outside one. And then this is 1/2, so it's become 2/3. 4 minus x squared 3/2 plus c. So yes, I mean you can simplify just a little bit. So you can write negative 1/3 4 minus x squared. Okay, so that means you don't need to do substitution, you can just write it like that. Just use the power rule or shortcut formula. Okay, but the problem is not this. The problem is when you have okay, so let's talk about this one. So what about this one? The next example, what about I just write 4 minus x squared without the square root 2. Now what happens? If you try to do this, you can do it now. Why? What's the derivative of the inside function? It's still negative 2x, but you don't have x there. So you cannot do this. Okay? So that's why. So we get stuck. Okay, we get stuck. So that's why we need the new method. So what's the new method? We're going to talk about 3 special substitutions. All things are like very much the same trick, but we try to use those 3 for 3 different type of integrals. Okay? So these are the substitutions. So it is what we call so this right, the 3 substitutions. Again, so we talk about 3 types. Like for example, if you get a problem like this, a squared minus x squared. If you get this kind of problem, okay, we're going to use this special substitution. We're going to use, for this one, we're going to use x equal a sine theta. That's the substitution. Okay. And here, theta is in between negative pi by 2 and pi by 2. That's where cosine positive. Okay. And right after we use a substitution, see what happened. See what happened if we use a substitution. So a squared minus x squared square root. So we substitute x equal a sine theta. So that means a squared sine squared theta. Okay. And we can take a out. So we take a out. Once you take a out, what do you get? 1 minus sine square theta square root. What is 1 minus sine square theta? Cosine square theta. Once you take the square root, it's become a cosine theta, but it shall be positive, so we put the absolute value of cosine theta. That means you can easily simplify. Okay? So that's the goal. We can simplify. Because we can simplify something like this. Okay? Actually, under this condition, see what condition we pick? We pick that theta has to be between negative pi by 2 pi by 2. Because of that, this simply becomes a cosine theta. Okay? Absolute value, we don't need absolute because it's always positive. Under this, this is positive, so you get that. The reason is cosine is positive greater than or equal to 0 at this in this interval. Oh, that's the first type. So the second type. The second type, when we have integrals a squared plus x squared, a squared plus x squared. If you have a squared plus x squared, we're going to use a tan theta. That's the substitution. A tan theta. A means a number, like this a can be 2. For example, 4 plus x squared. So a equal 2. So if you do that, and here the condition is it is pi by 2 without the corners. See, no corners. It's open interval. See what happened in this case. In this case, this becomes a squared plus x squared square root. This equals a squared plus a squared tan square theta. We take a out. We assume a is a positive number. Okay. Then you get 1 plus tan square theta square root. What is 1 plus tan square theta? Secant square theta. Once you take the square root, it becomes a absolute value secant theta. Under this condition, cosine is positive. Since cosine is positive, 1 over cosine, that means secant is positive, so you don't need the square root absolute sign. So this will become a secant theta. Okay? So it becomes a secant theta. The last one. we don't have much theory for this. So the last one is the other side, like they want to switch the order of the terms. So third one, what if you have a squared minus x squared minus a? This kind of integrals. If you get this kind of integral, you're going to substitute x equal a secant theta. Okay. So secant theta is in between 0 pi by 2. So this is like most of the time this is enough. Actually, this should be open interval, otherwise go to infinity. Most of the time this is enough. Okay. So under this, what's going to happen? A squared minus x squared minus a squared equal a squared secant squared theta minus a squared square root. As we did before, you can take a out. So it is secant squared theta minus 1 square root. What is secant squared theta minus 1? Tan squared theta. Okay, that's tan squared theta. So this simply becomes a absolute value tan theta, and this is a tan theta because in this range it is positive, tan positive. So that's the trick. That's what we do. Okay, we just try to rewrite the integral using tan trigonometric functions. Okay, so let's try to do 2-3 examples. So yeah, let's do the one we got stuck. What was that? 4 minus x squared dx. So we could not do that before, but now we can. Okay. So what substitution? It's for you now, okay? X equals okay. You have to write 4 as what? 2 squared. So what is a in this case? A equals 2. That's not this 2. This, okay. So it is 2 sine theta. You pick that number, whatever the number here, and put sine theta. And then we need dx. So dx is what? Derivative sign means cosine. So it is 2 cosine theta d theta. Okay. Now what happens in integral? What is the integral? So this is 2 squared minus x is 2 sine this, so this is 2 squared sine squared theta. Dx is 2 cosine theta. Okay. So 2 squared, you can take 2 out. It is 1 minus sine square theta square root. So we do the same simplification here. That's what we try to do. 2 cosine theta d theta. So it is 2 to 4. You can write it outside. 1 minus sine square theta is cosine square theta. And take the square root. What do you get? Cosine theta. And from this one you get another cosine theta d theta. So it is 4 cosine square theta d theta. Is that right? How to do a square? Using the half angle formula. Okay? So we use the half angle formula. So it is 4. What do you get? 1/2 1 plus cosine 2 theta d theta. And then you can do this integral separately. So you get 4 cancel is 2, so you get 2. And then 1 means theta plus what? Cos means 1/2 sine 2 theta plus c. Is that right? But now you can expand this one, so you get 2 theta plus 2/2 get cancelled, you get sine 2 theta plus c. But now the question is, can you leave it like that? Can we leave it like that? Theta is something we introduced. That was not in the original problem. Original problem was only in terms of x. So that means you have to replace all of theta. Okay? But that's not that difficult. What we're going to do first, we write theta, it's alright. This one we have to use the double angle formula. Do you remember sine 2 theta equal what? 2 sine theta cosine theta. Okay? So sine 2 theta equal 2 sine theta cosine theta using one of the trigonometric identities for the double angle formulas. Okay? Sine 2 theta equal 2 sine theta cosine 2 sine theta cos theta. That's how we normally say. Okay, that means we need to find the sine and cosine. 2 sine theta we already know. What is 2 sine theta? X. So this one is simply x. Okay. But do we know cosine and theta? We don't know. So we have to do something. This is what we're going to do. Okay. We're going to start with our substitution. What's the substitution? X equals 2 sine theta. Okay. So that means sine theta equals x divided by 2. Is that right? So that means theta equals sine inverse x divided by 2. Just take the inverse of both sides. That means this term is alright. Theta is sine inverse x over 2. But we still don't know what is cosine theta. So you can either use the Pythagorean identity, but we don't use the Pythagorean identity, we just draw the triangle. It's helpful. So we draw the triangle. Because we know that sine theta equals x over 2. That means if we draw the triangle, if you call this is theta, this is sine theta. Sine theta equals opposite over hypotenuse, that means x over 2. Is that right? So what is this from the Pythagorean identity? Square that minus that is square. So it is 4 minus x squared square. Okay, so you can find cos theta from this one. So what is cosine theta? Cosine theta equal 4 minus x squared over 2. Now we can plug in for this. Okay, so let's write the final answer now. So what the final answer? 2. What is theta? Sine inverse x over 2 plus 2 sine theta equal to x. Cosine theta is this. So that's the answer of the integral. Okay. So it's a routine work. I mean, you can see that every problem goes like that. Okay, every time you simplify, most of the time you draw the triangle and try to find the missing term. Because once you draw the triangle, you can find all 6 ratios. Okay, so that's the benefit of the triangle, rather than using the identity. But if you use the identity, for each separate one, you have to do a separate identity. But you don't need to do that if you do the triangle. You have all 6 there. Okay, so triangle is always useful. So use the identity, use this identity to draw the triangle. That's the thing. Once you draw the triangle, you can find any of these. Okay? That's the first example. So let's do more. It takes like a whole page. Okay, see the whole, yeah, almost. Okay. Just took the whole page for that. Like I said, exactly between 2 lines. Okay? That's the complete answer for the problem. Okay, so let's do more. This one is not in the book. Okay, this example is not in the book, but that's the easiest one you have to do. So how about this one? Example 2. Let's try, so evaluate 9 minus x squared square root divided by x squared. So what is the substitution? 9 you have to write first as 3 squared minus x squared over x. It's 3 squared. 9 you have to write 3 squared. So what substitution? X equal 3 sin theta. And then dx equal 3 cosine theta d theta. Okay, so it is 9 minus x squared square root x dx equal. Is that right?
Should be over your denominator dx squared.
Yep. Okay. So it is 9 minus 9 sine squared theta square root x equals sine theta, so this is 9 sine squared theta. Dx equal to 3 cosine theta d theta. Now let's simplify. What do you get? On the top you get 3 1 minus sine square theta square root over 9 sine square theta d theta. No, that's not d times 3 cosine theta d theta. And this 3, 3 and 9 get cancelled. The top becomes what? Cosine theta. Times this one, another cosine theta over sine square theta d theta. It's just a trigonometric simplification. What is this? This is cosine square theta divided by sine square theta d theta. What is that? Cotangent. Cotangent square theta d theta. Can we do cotangent? Is there a formula for cotangent? There's no. But can you rewrite a cotangent using some other functions? What is cotangent squared means? Cosecant squared minus 1. Is that right? Now we can do. What's the answer? What's the answer? Negative cotangent. And the minus theta, minus 1 becomes theta plus c. So we get the answer using trigonometric function. What's the next step? What's the next step? Draw the triangles. Because theta we can find, just take the inverse of that. So theta is fine, but we need to find the cotangent. So what we do? Draw the triangle. Okay? Draw the triangle. So let's draw the triangle. So where can I can draw the triangle? No. Mine was good. Because I'm going to move it last. Okay? So it is. So we know that. So we need to draw the triangle now. Okay? I can use this space for that, but make sure you separate that. Okay? So we know that x equal 3 sine theta, as we did before. So sine theta equal x divided by 3. So theta equals sine inverse x over 3. That means this part is all right. We know that. And then now we draw the triangle. So this is theta. Sine theta equal x divided by 3. That means this is 9 minus x square square root. Okay, from this one you can find cotangent. What's the cotangent? Adjacent over opposite. adjacent over opposite. So what's the answer? Is negative. Adjacent means 9 minus x squared square root. Opposite means x. Okay, that's the cotangent. Okay, is that right? And then minus theta is sine inverse x over 3 plus. That's the answer. Okay? Okay. Let's do more. I'm going to do 2 more. So those are all using sine. So let's do other substitution. Like, what about tan? So let's do one with tan.
Yeah, this one.
Alright? So let's do this one. Example 3. 1 over x squared plus 4 dx. So any guesses? Any guesses? You're gonna let x equal. You know that 4 equal what? Huh? Yeah, because 4 is 2 square. Since 4 is 2 square, we pick x equal to tan theta now. And where is theta? Theta is in between negative pi by 2 to pi by 2. So dx equal, what is dx equal to? Secant square theta. Okay, so now let's go these together. So it is 1 over x squared 4 square root dx. So it is 1 over x means 2 tan theta, so this is 4 tan square theta. And then this is again 4 tan square theta plus 4 square root. Oh, I need more space actually. I'm going to dx on the top, okay, because I don't have space there. So, and when dx is 2, secant square theta dt. That's what happens when you substitute. Okay. So there's a little simplification there. How you can simplify? The 2 you can cancel. You get secant square theta d theta over 2 tan theta, and then you can take 2 out. Once you take 2 out, you're going to get 1 plus tan square theta. What is 1 plus tan square theta? 1 plus tan square theta equal to secant square theta. Once you take the square root, it becomes secant theta. Is that right? So this is secant theta. This part is secant.
Why isn't that 2 tan square theta?
So what do you get? So this becomes secant theta. Okay, so what do you get at the end? I can write 1/4 outside. So let's write 1/4 outside. Yeah, so one of the secant get cancelled. So what do you get? One of the secant get cancelled. So you're gonna get secant theta divided by tan square theta d theta. Is that right? Okay, and what we can do is we can rewrite all of those trig functions using sine and cosine. Okay. So let's do that. If you do that, what is secant theta? 1 over cosine theta. What is tan theta? Sin theta over cosine. So this becomes sin square theta. Cosine square theta you can write top. Is that right? So 1 over cosine get cancelled. You're going to get 1/4. What do you get? Cosine theta over sin square theta d theta. This you can do using the general power rule. Because what is the derivative of the inside function? What's the inside function? Sin x. What's the derivative of that? Cosine. So it's there. So we can just use the general power rule. What do you get? So it's 1/4. Let's write this like this first. So cosine theta, sin theta, -2, like that. Now the derivative of the inside function is cosine theta is there. That means we can treat this as just x. So what's the integral then? 1/4. You add 1 and divided by that sin theta -1 plus 6. Okay. Just using the general power rule. Okay. Or it's just substitution problem, but you don't have to. Don't waste time for that. Okay. Just go with the power rule. It's much easier. Okay. So we have the answer now. So it is negative 1 over 4 times sin theta plus 6. Okay. So what we need sin theta. But we don't need sin theta, we know tan. Okay.
How did you evaluate that integral again?
Using the general power rule. The one we discussed at the beginning of the class today. It's much easier. I mean, you don't have to use the see, whenever you have the derivative, just treat this as x.
Okay.
See, you add 1 divided by that. See? Much easier. Okay, now we're going to use the triangle because we need the sin theta, and we know that x equal 2 tan theta. So that means tan theta equal x divided by 2. So draw the triangle theta. This is x over 2. Is that right? So what do you get here? You get 4 plus x squared square root. So what is sin theta? What is sin theta? X over 4 plus x squared, but you need a 1 over, so you can write upside down. Okay, so the answer is negative. Okay, so the answer is negative. Negative 4 plus x squared square root divided by 4x plus 6. Okay? Because you have to write upside down because it's 1 over. Okay? So that's the answer. Okay? Negative 4 plus x squared square root divided by 4. I mean, just leave it a work, but not difficult. But there are a lot of things to remember. That's the only problem with this. There are a lot of things to remember. Like whenever you get something other than your starting function, you have to draw the triangle. Okay? From the triangle, you can get any function. Okay, so let's do one with secant. All problems are like that. Like it go with you have to identify the form first. Okay, okay. So let's do one with secant. How about this? Example 4. Dx over, let's say, x squared minus a squared square root. And where a is positive. A is positive, it's given. Because a is negative, you get a lot of troubles. Okay, how about this? So what's the substitution? What's substitution? X equal
A
a secant theta. Okay. So dx is a secant theta tan theta d theta. Okay, so let's substitute. Dx over x squared minus a squared square root. Dx is a secant theta tan theta d theta. X equal a secant theta, so it is a squared secant squared theta minus a squared square root. And then let's simplify. You're going to get a secant theta tan theta d theta over, you get a out, you're going to get secant squared theta minus 1 square root.
Is the original equation supposed to be x over?
What is it?
Is the original equation supposed to be the integral of x over? Or
Dx,
1
dx.
over?
Dx over
Okay.
x
So-
squared minus a squared square, it's like 1 over.
Yeah.
Uh-huh.
So you plug in a secant theta tan theta. on
You mean
the
this
top.
one?
Wouldn't
Yeah.
that just be d theta up there?
No, because once you take, because x equal a secant theta,
Yeah.
so what's the derivative of secant theta? Secant tan.
Oh, okay.
Yeah, so dx equal a secant theta tan theta d theta. So there are three things. It's like, it comes here because of dx. Okay?
Got it.
Because I replace dx by that, the big one. This is what happened for any function we use this substitution. It doesn't matter what the function. For anything you have to use it. And you can see the benefit. It's useful. Okay? It's useful. You can see in the next line you're going to see the benefit. Okay? So you have a secant theta tan theta d theta divided by a. What is secant square theta minus 1?
10.
Tan square theta, once you take the square root, it becomes tan theta. Now what happened? This tan and this tan get cancelled. See the benefit? It's gone. What do you get? And AA also get cancelled. So you simply get secant theta d theta. Secant theta we know. What is the integral of secant theta? We did last time. That's one of the other formulas. There were three other formulas, remember last time? The third one, what is that? Natural log. Natural log. Secant tan. That's the integral of secant theta. Natural log secant tan. So we basically done the integral, but you cannot leave those tan and secant thetas. So what you do? Draw the triangle. Let's draw the triangle. So what we have x equal a secant theta. In other words, secant theta equal x over a. Is that right? So if you take the reciprocal, cosine theta equal a over x. It's easy to handle. Okay, I mean, otherwise it's okay. Now we can draw the triangle. What's the triangle? Theta adjacent over hypotenuse. So this becomes what? A squared minus x squared square root. Okay, so you can find secant tan. Or secant we already know. Secant is x over a. So we can plug it here. So it is ln secant theta equal to x over a. Okay.
Shouldn't x be the hypotenuse?
Yeah, you're right. Okay. So so what happened? Yeah, let's switch. Okay. So this is a and this is x. Thanks. Okay. So this is x squared and a squared. Is it right? That's right now. Okay. Good.
Yeah. Good.
So so secant theta is x over a. What is tan theta? Tan theta is x squared minus a squared divided by a plus. That's the answer. So that's the kind of okay compared to all the other examples, because the previous ones were difficult. Yeah, this is just get an easy one, but the other one was not that easy. Not that easy. Okay, so those are the three types. Okay, we had a sine, tan, and secant. Okay, so only thing is like at the beginning of the integral, you need to figure out which substitution you're going to pick. If you have a squared minus x squared, you're going to pick a sine theta. If you have a squared plus x squared, you're going to pick a tan theta. If you have x squared minus a squared, you're going to pick a secant theta. That's it. Okay, those are three substitutions. That's how you start it, and the rest of the things is coming from the rest of the function. Okay, so let's do more. Just more examples if you want. How about this one? How much time we have?
10 minutes.
10 minutes? Yeah, probably I'll show you this one for that one. So how about this? I might do a different paper. Sometimes what happens, we get these kind of integrals. What is this? For example. Example 5. No, we don't need that. Let's do this. How about something with numbers? We didn't do anything with numbers. And this is not in the book. Okay, so let me try this one. With number, square root 2 to 2, 4 minus x squared over x dx. So what's the guess? X equals 2 sine theta, is it? And now we need to find the new limits. Okay? So when x equals square root 2, what is theta? When x equals 2, what is theta? When x equals square root 2, what happens? X equals square root 2. So this becomes square root 2 over 2. For what theta you get square root 2 over 2 for sine? When you get square root 2 over 2 for sine? Pi over 4. And when you plug in 2, 2 get cancelled, you get sine theta equal 1. So what's the theta? Pi over 2. Okay, that means those are the new limits. Okay, so let's plug it. So the top, so the new limits become pi over 4 to pi over 2. This is 4 minus 4 sine square theta square root. X equal to sine theta. And then what else we have? D theta, dx. So dx is 2 cosine theta d theta. Okay. What do you get? You get so this is, you get a 2 here. So these two get cancelled. You get 2 pi over 4 to pi over 2. And then you're gonna get you're gonna get 1 minus sine square theta square root sine theta cosine theta d theta. So this 2 pi over 2 to pi over 4. This is a cosine theta, so you're gonna get cosine square theta. Is that right?
You just get cosine.
Cosine square theta. What else you get? Sine theta?
Yeah.
Or sine theta, okay? Divided by sine. Okay, so now what we gonna do? So any methods? Now what we can do? Yeah, so what substitution we can pick?
For sine theta or sine. Just make it negative.
Yeah, so what we can do? You can substitute for cosine theta. So what is that? Cosine theta equal? Cosine theta equal? We can write this as cotangent and cosecant. That's not going to help you.
Cosine squared theta, 1 minus.
What about you write this cosine as 1 minus sine square theta? Is that right? Now what happened? Now you can break it. Now you can write this as 2 integrals. Okay? So you can write, with the first one you can write 1 integral. So it is 2, what is that? Pi over 2, pi over 4, cosecant theta, d theta. That's the first one. Is that right? Because 1 over sine, that means cosecant. What about the next one? Pi over 2, pi over 4, sine theta.
For your limits, when you said pi over 2 to pi over 4, you put pi over 2 as the top limit. Is it supposed to? Oh wait, no, never mind.
Pi over 2, pi over 2, pi over 2, pi over 2.
Okay, wait, never mind. Okay.
Okay, what about this one? This one also has an integral actually that we did not discuss last time. The integral is like this. It is ln. Remember, for the sine, for the secant, what we get? We get secant tan. Is that right? For cosecant, we get cosecant cotangent. Minus cotangent. That we did not discuss. So that means we don't ask this like this. It should not simplify that. Okay. So minus. This one we can do. What is 2 sine theta? Cosine theta. Is that right? That is plus cosine theta. Okay. Now we put the stroke pi over 2 and pi over 4. So just try to plug in pi over 2 and pi over 4 and simplify. Okay. I'm going to use that part for you. Okay. So you can see that right after we slightly change the problem, it's a different integral. Okay. I mean, what to do? You can't do anything.
I know you said it before, but can you repeat what equations we're going to be allowed to be given? Are we giving any?
No, we are not giving any equations. So as far as I know.
So we have to commit them all to memory, you're saying?
Yeah.
Do all the cases too?
Yeah.
Okay.
But,
Thank you.
But this is what we try to do. We try to ask some questions that you can manage in that time.
Okay.
So we are not going to ask like any question you have to spend 30 minutes. No. Like 5-minute question.
If you're in like a lab or something, you're like given
Yeah.
I mean, like for instance, that's why my chemistry allows us to have note cards. He doesn't want us to worry about memorizing the formula. He wants us to memorize how to use it.
Yeah. And it shouldn't be about memory.
Like,
Nothing to do with math should ever be
here we have a squared minus x squared. It has to be. Then we have x squared minus a squared. The first order
That makes it so much better.
Fun.